Okay, the first thing that you guys mentioned that you wanted to go over were things like the limit as x approaches 0 of sine 5x over x. Okay, and this was a situation where you could really shortcut it. There was math behind it. We multiplied by things and made it work. But the shortcut was just to look at the number in front of x up here and the number in front of x up here and see what those made. So 5 over an imaginary 1 would just be 5. Another example, it could be upside down. So if I had x over sine 3x, what would my answer be? 1/3. If I had the limit as x approaches 0 of 2x over sine 9x, what would it be? 2/9. Okay, that was what you had to remember there. I'll show you the math behind it again in case you needed that for some reason. If I have, say, the limit as x approaches 0 of sine 2x over x, obviously we know the answer would be 2. The way we came to that was by multiplying by 2 over 2 and putting that 2 with this x and moving this 2 to the front. So you would be looking at the problem as this. And now those match. You know that the limit when they match is what? 1. So you bring down this 2. This whole thing, the answer is 1. And so the answer is 2. But again, if you realize that's one of those shortcuts, you could realize that was 2 in the beginning. Okay, so the question has come up, what happens if it was like a 2, whoops, if it was like a 2 sine, I don't know, 3x over x. This 2 can be moved but out front like this, so it'd be 2 limit as x approaches 0 sine 3x over x. And again, when you look at this, you know the answer is 3. So you can just bring down that 2 and then look at this answer is 3 and get a 6. And so Nathan, this answers your question about what if there was a number in front of the limit. You just bring it down and multiply. Okay? Yeah, it's just one less step than what I have. Okay, the next thing that you wanted to go over was derivative rules. So basically, let's test you for a minute. What is the derivative of y equals 3 to the x? Three to the x times the natural log of 3. What is the derivative of arctan x? 1 over 1 plus x squared. What is the derivative of natural log x? 1 over x. What is the derivative of log base 3 of x? Nope. 1 over x times the natural log of the base. And it might be absolute value. I'm having a brain fart. Okay, so it is not absolute value after we have checked that. So it is 1 over x natural log 3. Okay, so we have done arctan. What about arccotan? If you know arctangent, you know arccotangent because it's just -1, negative version of that. Okay, what about arcsine? Yes, 1 over the square root of 1 minus x squared. What about arccosine? Yeah, arcsine and arccosine are the ones that are kind of paired together. So if this one's positive, this one's negative. Okay. Let's see, we haven't touched arcsecant. Yes, 1 over the absolute value of x. That's where our absolute value is coming in that we were wanting to use. Square root of x squared minus 1. So it's the opposite underneath of these. And then arccosecant forgot my prime, is what? Correct. Okay, so those are all of your arctrig. Let's see if you know, what is the derivative for the absolute value? Absolute value of x over x. Okay, let's test your trig. Derivative of sine, cosine. Derivative of tangent, secant squared. Derivative of secant, secant tangent. Derivative of cosine, negative sine. Derivative of cotangent, negative cosecant squared. Derivative of cosecant, negative cosecant times cotangent. Okay, so here's a mixed example that you have to think about. This is the kind that you guys miss a whole lot. So what is the first thing that you're supposed to do? Move the 3 to the outside. So 3 cosine squared, you're doing the powers first, 5x squared plus 1. So absolutely nothing changed except for the powers. Then what? Then you change the cosine to a negative sign. You take its derivative. So negative sign. Do not change what's in parentheses at this point. And then what? Then 10x. Then you do the derivative of the inside. You do chain rule. So you did the powers, then the cosine, then the total inside. Because it's just taking it one step at a time. It would be the same problem if I had written it like this. So if I'd had cosine of 5x squared plus 1 cubed. See, that power, you do the power first, then just the cosine. You've already taken care of the power. And then the inside. This and this are the same thing. So if you need to rewrite your problem when you see it like that, in this manner, do it. Okay, so for another example, what's going on here? What do we need to do? Product rule. You have x's in this part and x's in this part, so let's see if we can do it correctly. So with our product rule, you do the first, so I have 2e to the x times the derivative of the second, which will be what? To the negative 1/2, right? Times 7, you got to bring that down. Times 3 to the x times natural log of 3, correct? No, and I'll address that in just a minute. Plus second, which you could put it to the 1/2, or you could put it the way it is in the original problem. Derivative of the first, 2e to the x. Now, let me address what Nathan just asked. He said, can you just put, can you multiply these, 21? No, because the 3 is to the x power. It's not just a 3, because you don't know that x is 1. If x was 1, then that would be 21. But x is a variable, so we don't know what it is. And remember that exponents come before multiplication in your PEMDAS. Alright, so your limit definition of a derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, I doubt you're going to need to find it by hand. Where you're going to see this is those problems where they have went ahead and plugged it into something. Let me find one. Okay, so I am writing an example of where you might see this. Whoops, ignore that. Alright, so, hey, stop laughing. You can see limit problems in your multiple choice questions that are basically forms of this. And what they're expecting you to do is realize that this is your limit definition of a derivative. And so you want to look over here and find what your f of x is. They don't want you to do all that work that we did before. They want you to say, okay, that means that f of x is x squared plus 2. And so I can just shortcut it to the derivative and my answer will be 2x. If I did all that work, I would come out with 2x. That's where you're going to see it. That's what. Okay, so another thing that you guys brought up was talking about midpoint rectangles, wanting to know how those work. So you'll have a function of some sort. I made an easy one. And an interval. Pay attention to the interval. If you guys remember, there was a test where the interval started at 1 and not 0, and a lot of you missed it because you started at 0. So I'm purposefully making this one between 1 and 3 so that you'll pay attention. Well, if we're going to do 2 rectangles, because, you know, sometimes they'll tell you how many, so we'll say n equals 2, between 1 and 3, that means there'll be 1 in here and 1 in here. So imagine where they fit first. You can even draw them understanding that they are touching at the midpoint. So the midpoint between 1 and 2 would be right here. We'll talk more about it in a second. That's where, and it's very hard to draw horizontal, it's going to touch and make your rectangle. The midpoint between 2 and 3, that's where you're going to get your height from and make your rectangle. Okay, now, what the hard part is coming up with those heights. So you have to realize what these are, and you could do them in decimal, but you know me, I like to work in fractions. So this is 1.5 or 3 halves. This will be 4 halves, so this will be 5 halves. You need those as your x values to plug them in to get your y values. So 3 halves, plugging it into the f of x, 3 halves squared would be 9/4 plus 1. 1 is 4/4, so 9/4 plus 4/4 is 13/4. Then the same thing with the 5 halves. 5 halves squared is 25/4 plus 4/4 is 29/4. And then if you're trying to find that area, you're going to add those up. Just length times width. So the base is 1. The height is 13/4. And then for the other one, again, the base is 1. the height is 29/4. And so you basically end up adding 13/4 and 29/4, so 39, 30, 40, 42/4, which will reduce to 21/2. And again, I like working in fractions because, on a non-calculator part, it's easier to do the numbers there. But also pay attention. If you're given a table, these, and sometimes on graphs, these may not be equal widths. They may have you doing things that are not always a width of 1. So pay attention.